Hello and welcome back to Electronics Teardown. Today we will start with a video series on analog to digital converters, ADCs. So in this series we will understand what is a analog signal, what is a digital signal, and how we can convert an analog signal into digital signal. Then we will try to create one circuit on breadboard to understand how an analog signal is converted into digital signal and what is the importance of bit resolution and sampling rate and other factors which will affect analog to digital conversion of a signal. To understand analog to digital converters, we need to understand first what is a analog signal. So, analog signal is a signal which can take any value between the defined limits at any instance of time. Let's plot the graph and try to understand how it will look like on a timeline. So we have took one graph. This is the x-axis, this is the y-axis. On x-axis we are representing time. So let's say we are representing time in hundreds of milliseconds. So 100 millisecond, 200 millisecond, 300 millisecond, and so on. And the y-axis represents the physical quantity, or you can tell represents the magnitude of any physical quantity which we are intended to measure. So analog signal will looks like, means it can take any value between the defined limits. Now let's say the defined limits is 0 and A, capital A. So it can take any value at any instance of time. So if we'll plot the graph, it may looks like this. Let's suppose we want to measure speed of any vehicle. So as you know, the speed of a vehicle can take any value during its operation. Like we have started the vehicle, so from the beginning it will start from 0. It can take any value at any instance of time. So this is speed, this is time. So this speed can take any value at any instance of time within the defined limits. So let's say the maximum speed of a vehicle is defined 150 kilometer per hour. So this is our upper limit, 150 kilometer per hour, and we plot the graph between the speed and the time. So the graph will comes something like this, means a vehicle can take any value at any instance of time depending on the driver or the situation or the road conditions or whatever it is. So but the point is, this type of signal is analogous in nature, means it can take any value between the defined limits at any instance of time. Let's suppose we have one photo sensor. So a photo sensor will sense the light intensity in the atmosphere. Light intensity in the atmosphere. So let's suppose we have kept that particular photo sensor outside our house entire day, and during evening we took the logs from the photo sensor and we intended to draw a graph between the light intensity and different hours of the day. So again, this will be our time and this will be the eye intensity of light. So how the graph will looks like? After sunrise, the intensity of light will keep on growing throughout the day and it will be maximum somewhere around 12 noon. Post that, the light intensity will keep on decreasing. So the light intensity will keep changing throughout the day, and at any instance of time, the value can be anything between the defined limits. So all the physical quantities in nature, for example, speed, light intensity, pressure, temperature, anything which we use to measure is analogous in nature. Now, why we want to convert an analog signal into digital signal, how we can convert an analog signal into digital signal, and what is a digital signal, we will understand. So before that, I will show you a demo of an analog signal so that it will be more clear to you to understand what is a analog signal. Then we will jump in like what is the need of the conversion and what is the digital signal and all those questions. As you can see on screen, we are having a photo sensor here. So this is a photo sensor circuit. This is the photo sensor, and we are using this Arduino board just to power this particular circuit. We will try to take different readings at different intensity levels. So here's the multimeter, and if I try to check the value, so you can see like it is 0.008 volts. So means at this particular intensity, the voltage which the photo sensor is generating is 0.008. Now let's try to change the light intensity and see what happens, and then we will try to identify which type of signal it is and why it is that particular type of signal. So to change the light intensity, I will use some torch light. So I'll change the light intensity and let's see the effect. So I'm using my mobile torch light for that. So as you can see that the value changes from 0.008 to 0.044 something, and as we keep on increasing the exposure, you can see as the exposure to the light is increasing, the voltage is also increasing. So it is 2.2 somewhere around, and it is going maximum up to 4.7 something. So you can see like just by changing the intensity of light, the voltage is changing. So in previous experiment, what we observed that the light intensity is changing and it is taking any value between 5 volts to 0 volts, as I am supplying maximum 5 volts to the system from Arduino board. So it can take any value between that depending on the intensity at that particular instance of time. So this type of signal is analogous in nature because it is taking any random value depending on the physical quantity, and the physical quantity in our previous experiment is light intensity. So these type of signals are analog signals. And as already mentioned, the other examples of this analog signals can be any physical quantity in nature. It can be either pressure, temperature, speed, and voltage, current, light intensity, so and so on. So any physical quantity in nature is analogous in nature. Now in next video we will understand what is a digital signal, and then we will try to get the answer why there is a need to convert an analog signal into digital signal and what are other complexities designing that particular system. Thank you.